Welcome. My name is Opubo Benebo. An aspiration of operating a subsistence farm is the harvest of higher productivity. Of course, it is well documented that generally productivity increases obtained when processes are performed under conditions of division of labor. Then, of course, division of labor at its essence is the performing of several tasks concurrently, the end results of which converge continually until into a single outcome. Subsistence farming, however, is often undertaken by just one, and rarely but occasionally by more than one member of the same family. And even in the latter context, the tasks that ought to be performed concurrently often outnumber the farmhands. Notwithstanding, concurrency of performing of tasks ensures relatively higher productivity and is preferred. One approach to accomplishing such concurrency of performing tasks is the automation of certain of the farming activities that will have been formulated into routine work, which by happenstance have been so organized into processes as per episode 9 and suggested to be integrated into a farm-wide process. In synopsis then, this episode, entitled Farm Process Automation Controller, offers the broad brush design and implementation of a controller system suited for the automation of farm process, such as to establish parallelism of the performing of the crop-specific processes of the farm. Instructively guide the selection of the instruments, such as sensors, signal systems, and control devices, and also give generalized integration of the instruments to provide a coherent controller system that supports and enables farm processes concurrency of tasks occurrence. The driver rationale underpinning the proffering of the farm process automation controller has the object of ensuring that every harvest of the subsistence farming operation results in relatively higher productivity than otherwise possible by the enabling of the concurrent performing of the farming activities. The tools for implementing automation generally are dependent on the process measurables and controllables together with established performance metrics. Also, as is generally known, the automation of processes are enabled with such core devices as programmable logic circuits, PLCs, which are configured to work with sensors and control devices such as pumps and flow devices such as valves and venturi. So, the one invariable device that a farm process automation controller must also have is the PLC, and may likely have one allocated for the process of each ridge of singular process. By happenstance, the electrical panel cabinet makes for a suitable housing for mounting the PLCs as well, and should be presumed to be mounted in the cabinet. For subsistence farming, though, some of the metrics and measurables were already identified as including the flow rate of water onto the ridges, the length of time of sprinkling the water onto the crops plants, and the degree of wetness of the ridges soils. So the selection of tools, or more specifically instruments for the process automation controller system, must necessarily be such as to evaluate these variables of the farming activities. Temperature sensors, and not just thermometers, must be deployed for temperature control tasks. Humidity sensors must be used instead of mere hygroscopes. And when the water is sprinkled as in aerosol form, then a photolite detector may be deployed to measure the absorption intensity to evaluate the watering activities efficiency. In addition, electrically controlled check valves and throttle valves must be adopted in place of manually controlled valves of similar class. In particular, the water sprinkler valves must be the electrically controllable sort. Needless to state that these instruments are being procured in addition to the core controller devices, which consist of the PLCs, and optionally as the HMI, Human Machine Interface, which is a software that displays the status of the variables at all times. Optionally, a farmer may also allocate one PLC per controller variable, but that may not be necessary in many cases. Both the sensors and the controllable devices are ordinarily connected to the PLC, and a single monolith PLC would be sufficient for the variable control needs per ridge. For more specificity, the presentation, for deductive reasons from here on, has the development of the controller system contextualized upon the process of the only cropped black-eyed peas that has been farmed or planted. As observed, the variables of interest in the farming of this crop are the wetness of the soil, the time lapse of sprinkling the water onto the plant, the watering of the composting, producing the biofertilizers for fertilizing the soil, and the repetitiveness of the task sequence towards establishing a routine. So, assembled at a minimum for the controller system of the process of this ridge is a monolith PLC together with soil wetness sensor, electrically controllable flow valve at the sprinkler device, a pump controller, a hygroscopic meter sensor, and photolite absorption sensor for the initial development. More devices may be purchased as necessary, but for the initial studies this will be sufficient. The configuration of these instruments and devices are straightforward. The soil wetness sensor is inserted into the soil, and the electrical output end connected to the PLC. The photolite absorption sensor is deployed lengthwise with the light emitter at one end of the ridge and the light receiver at the other end, and the differential processor is then connected to the PLC. The hygroscopic meter sensor is inserted into the biofertilizer bioreactor and then connected to the PLC. The controller device, pumps, valves, venturis, if any, are also connected to the PLCs as per instructions. The pumps of the water delivery pipes by the ridges are paired with the photolite sensor and soil wetness sensor, so the signals sent by these sensors are reacted to through the pumps and flow devices of the pipe. Similarly, the hygroscopic sensor of the bioreactor is paired with the water pump and control valves that let water into the bioreactor, and also paired with the drain valve of the bioreactor, so that the signals from the sensors are reacted to through the valves that specifically correct the variable. For instance, the water feed pump is turned on and the valve open to address dryness, or the water feed pump is shut off and the drain pipe open to drain excess water. A programming paradigm from among ladder logic, structured text logic, or some other method is then chosen and implemented in the PLC for actually effecting the dynamics of the pumps and the valves, and the device is installed to control the state value of the variables being controlled. After appropriate testing and acceptance of performance, the subsistence farmer can be assured of having been empowered to support concurrency of farm activities execution, and for all intents and purposes, the lone farmer will have also augmented available hands with automation. The conclusion that is being drawn at this time then is that a subsistence farmer can be significantly upgraded with process automation controller and consequentially enjoy bountiful harvest without working self to exhaustion. Even more significantly, the farming activities get to be very integrated, such as the integration of the biofertilizer production process to the soil fertilizing needs schedule as presented earlier. Even so, an aspect of automation development presented so far is that the scope is merely a broad brush and the actual implementation is far more involved than preferred. The fact is that as the farm gets larger, though still subsistence in objective, the automation may modify into adopting a distributed controller system, and this system reintegrated yet again into distributed computing system of distributed controller system, and even into a more complex infrastructure than stated. Nonetheless, the adoption and implementation of farm process automation controller system brings to the aid of the subsistence farmer all the benefits of division of labor and the consequential benefits of parallelism of tasks performing, and hence acceleration of compression of farming activities into season-constrained time spans. And it is a wrap. On that note, I say to you, thank you so much for having come to listen to this observation about efforts aimed at alleviating world hunger through subsistence farming by both urban dweller farmers and emergent countries' small farms farmers. You are truly appreciated. And if you like to get privileged viewer-reader information, access podcasts of specialized contents, or even vertically integrated concepts, then I implore you to join my supporter group and enjoy that privileged status. Thank you. Meanwhile, while still here, do please take a moment and subscribe to the channel as to be informed of the publication of every new episode as soon as it is released. Bye. Till next episode.